Alright guys, what's up? Well, as you know, for these videos I go over what I did every week, and as you guys know, last week we actually finished a book. That's huge because this is now going to be our third book that we're going into. This is week 17, alright? And so the first couple of weeks we did our first beginner's Python book. Then the last couple of weeks we've been doing our first EDA book, which is basically just, exploratory analysis, beginning of stats, learning how to use Jupyter notebooks, and now we're moving on to a little bit of machine learning. Now, before we get into machine learning, we got to really learn the fundamentals of machine learning. And for me, that's all based on statistical learning. So that brings me to this video, which is the start of a new book. And something you might have noticed, every time we start a new book, I kind of change things for the videos. The first time we were actually here in this same location, but we didn't have a mic. Then we moved location a little bit more to the left of the bookshelf, and we had a mic. And then now we are in our third book, and I've switched back to the bookshelf, and we still have the mic, but now we have a wide lens. So I don't know if you guys have noticed, but the wide lens does add a little bit more depth to the shot, makes it a little bit nicer, and I would love to know what you guys think. So let's get started with the video. Now, as always, with every video, I start off with what I learned really quickly, and then I move on to like more in depth of what I've been learning. So, like I said, I've been learning statistical learning. This book is called The Intro to Statistical Learning with R, and it is written by a couple of the people who kind of were pioneers of statistical learning. Now, they wouldn't call themselves that, but they were there at the very beginning in the 80s and 90s when the statistical software R was created. Now, R is a statistical software that's used a lot all over the industry, but because of our practices being more generalized, we are just going to use Python. So all their questions can easily be answered using R, but can also easily be answered using Python. So that's what we're going to do. So without further ado, let's talk about what chapters I did in this book. So in this book, I did chapters 1 and 2, of course. The first chapter was all about notation and just an overview of what we're going to learn in each chapter. Simple enough, right? And then in chapter 2, we learned all about kind of how to set up a problem with a function, and basically a function that we're going to, well, let me correct that. We have a y, which we're trying to predict, and we have a function that we're going to use to predict y. And this function, we learned how to set it up and how to add basically an e variable. And this variable is basically the error that's irreducible. And I'll talk more about that once I get more in depth. And then lastly, in chapter 2, we talked a little bit about nearest neighbor averaging and about supervised and unsupervised learning, and and the curse of dimensionality, which is very important when doing nearest neighbor, and very important just to mention like in general in statistics, because it talks about the problems that can arise when using multiple features, too many features. So alright, so that's kind of the overview of what I learned this week. Now, if you want to stay in for more in depth of the video, stay tuned. If not, you're free to leave a thumbs up if you liked it, and go enjoy learning statistical learning. But if you're gonna stay, let me go more in depth what I learned in each chapter. So like I said, chapter 1 was just on notation. We learned all about f and f of x basically, and how we can also have f of x with a hat. Now, the hat basically means that we figured this out. We figured out this f of x using a testing data set. So it's really an estimation. It's not the exact formula. So you can use statistical software to create a model and use a formula to create that model, but then you can forget about that perfect f of x and try to use statistical learning to figure out that f of x. And so that f of x that you're using to predict is actually the f of x with a hat on top. And you do this for every variable or every coefficient that is basically estimated, that you made up. Now, we use capital Y to be kind of what we're trying to figure out. That's, in an example, that would be, let's say we have three different variables that are TV, radio, and newspaper. And they would be in dollars. Those will be the amount of, well, no, sorry. That will be the amount of ads. And then in the end, we'll have sales. So sales will be our Y. And let's say we want to use, actually, this is getting into chapter 2, never mind. So let's just go with that. And then we also learned the notation of X and, big X, capital X, and how we can use that to kind of be a matrices of different features or variables, and those are our X. Like I mentioned in this example, that would be the TV, the radio, and the newspaper, and we kind of represent them all as a capital X, or they could each be an X and a 1 for radio, X sub 2 for newspaper, and so on. And you can kind of have an infinite amount, right? You can have a lot. And that later on we'll talk about Curse of Dimensionality, which is really important, but for now we'll stop there. And let's see, we also learned, like I mentioned before, epsilon, which is an E, and we use that to do error, and that's going to be our irreducible error. That's going to be how much we deviate from the real answer from the model f of x, and how much our f of x of hat is different. So we use that estimator, and we always add it on at the end. Sorry, not estimator, that error, and we always add it on at the end. Now, there's two different errors. There's reducible error and irreducible error. The reducible error is basically what we can, through better models, more thinking, more brains, fix and make our model very, very good, our estimator very, very good. But we're never going to get it exact, right? And so we're always going to have that little e on the end of our estimator function. Cool. Now, moving on to chapter 2. Chapter 2 is super interesting. I'm super happy that they started with this and not linear regression. Linear regression is actually chapter 3, which I kind of started, but I didn't go into depth, so I'm not including it. But wow, we learned all about the Curse of Dimensionality, which is amazing. They did such a good job explaining that in the book. We also learned about nearest neighbor averaging. So this idea is actually really great, and let me tell you about it. So nearest neighbor averaging, you have, for example, let's say you have, you're trying to look in a function, right? A line plot, sorry, not a line plot, a scatter plot of different points that you have from your model. And you're trying to predict what's the y at x, correct? So you have an x and you want to know what that is, let's say at x equals 4. So you're trying to find out what y is equal at x equals 4. Now sometimes you might just happen to have a point at x equals 4, and you can look at the y and you would probably guess that. But funny enough, sometimes that doesn't happen. Sometimes you have an x of 4, and in your scatter plot you don't find any x of 4s. You have maybe an x of 4.1, 4.2, maybe 3.9, 3.8, but not at 4. So what do? So in this case, you would do nearest neighbor averaging. And so basically what you get is you would find 4 in the middle, and you would find, kind of have 10% on one side, or 5% on one side, 5% on the other side, to kind of catch the ones that are around it. And then you find the average of those, and then that's what you would guess. And this happens to be a very good predictor. Nearest neighbor averaging. It's very, very good. Doesn't work all the time, but it's very basic and almost a necessity in some cases. Now, funny enough, this is where we start talking about the curse of dimensionality. In the curse of dimensionality, you kind of have this, this saying basically, which is, well, it's not a saying, it happens in practice, but it's, a curse because you run into problems once you have too many features or variables, like we mentioned before. It just so happens to be that every time you have another variable or feature, you go up one whole dimension in uh, your analysis or in your radius of trying to catch points. So, like I mentioned before, in the scatter. Alright, guys, so you wouldn't believe my camera just shut off, but now we're back. We were talking about Curse of Dimensionality. So, I was mentioning how at first, when you have one variable, you do 5% to the left, 5% to the right, you get 10% radius to see where the nearest neighbor values are, and then you find the average. But once you go up a dimension, you actually end up with a radius. So you end up with the circle like this, and then past that, you go in a bigger radius, bigger radius, bigger radius until to the point where you have, I don't really remember the exact numbers, but if you have like 10 variables, you're getting most of the data just to trying to find this one point. So it stops being accurate very quickly. I mean, it works very well in the beginning. It's just, the curse of dimensionality. So that's how that works. And other than that, chapter 3, I started it but didn't go into it, so I'm not going to do that here. And yeah, that's all for today's video. Next week, I'm going to do chapters 3 and chapters 4. I'm really excited. Linear regression, again, is something I kind of know, but this book is doing a really good job at really pinning down what you need to know, the formulas, the examples, the good, the bad, and how to do it in statistical software. So I'm super excited about that, and I'll let you guys know more about that in the next video. Also, if you guys haven't noticed, I uploaded recently my EDA. This is my first EDA that I've posted, and it's on the COVID dataset. Now, I've been talking about doing it for a week or so, and I finally did it, and I posted it. It took me a while to get the environment set up, but I did it, and I just want to let you guys know, if you like that, please head over and watch that. I'm going to be doing more COVID datasets. I'm going to be doing a little bit more analysis in those datasets, and then I think I'm going to move on to a little bit Kaggle competitions. But if you guys want to stay tuned for all of this, just let me know. And that's it for today's video. So thankful for you guys joining me, and I'll see you next time. Peace.